So today we're going to take a look at two new features that we are going to explore today. One is the external threads, and two is the hole feature with using threaded holes. Now, again, we could use these for whatever kind of devices we want to say lock down things, to create the screws or create the holes that we want to use to secure items together or for them to be secured with other items with them. So let's go ahead and take a look at what this looks like. So the first thing we're going to do is I created this project right here. It's a simple square, 2 by 2 inch, extruded down to 3 inches from the top plane. So what we're going to do is, all we need to do start off here is to create a new sketch on one of the planes, and I'm going to use this plane right here. Now, the system's running a little slow right now because I'm getting a poor connection notice. So now that I have this connection here, what we're going to do is going to come up here, and I'm going to take this point tool, and I'm going to put it right here on the plane that I'm working on. Now, it doesn't matter where right now because I don't need to have this dimensioned to any particular place, so I'm just going to leave it right there. Okay, and now that the point is on there, I'm just going to finish my sketch. And now I'm going to go into my hole command. And when the hole command opens up for us, what we're going to do is we're going to take a look at the hole and its many different types of features. So here is our hole command with a bunch of different commands. Now, the first drop down box here is the style of the hole that you have, and if we click on it, we have simple, we have counter bore, and we have countersink. So let me make sure that we have our point selected, and I'll show you what those look like when they change. So right now the counter bore hole is going to look a lot differently than the other holes, and we could use these in different change. So with the counter bore, we have a hole that has another hole in here, so it has a lockdown so that it goes flat against it, and it has a more cylindrical shape. Then the countersink has a different type of shape for it. Now, when you have the countersink one, it's more of a tapered design for the hole, and so you can have more of a screws in here instead of a bolt with the other one. But for us, we're going to go ahead and we're going to stick with a simple. Okay. And for the simple, we're going to choose the blind so that we keep it at a certain distance. And there are other options for this one too. So it can terminate at a distance, through, or start from the inside and work backwards from blind to last. Now, our next is the standard. So when we look at here, there are different types of standards for screws. NASI, there's the ISO, the DIN, and the PEM. Honestly, only worry about the first two because those are the most two common. But if you're working on custom and you're doing something specific, then you have to create your own type of hole and screw. Then you use the customs. So we're going to leave it at NSI. Now, we're going to use a different type. So there's clearance, tapped, drilled, and tapered pipe tap. Now, tapped means that they have a screw end at one end and not all the way through. Of course, there's drilled. That means it goes all the way through, so you have the screw holes. Clearance as the distances, and the tapered pipe tap, but we're just going to use the tapped for now. Now you specify the size. Size is, especially with ANSI, you can go all the way to 4 inches. So let's leave this at like 5/16. Okay. Now, when I change that, it'll have an effect on here. Now, next one is threads per square inch. So now I change these to 18, 24, 32. So for every inch, that's how many threads you'll find in that area. So we'll put it at 18 threads per inch. I don't usually change this, the diametric engagement, so that's fine. You do not want to change this next one right here, because this is going to change the diameter. The diameter is already set by the size. Skip that. Next, we're going to come down here to the depth. How far back of a hole do you want? So in this case, I have it set to 1 inch or 2.54 millimeters. Now, the tip is the back. So as you see here, and I'll zoom in a little, this is in here. So this is what the inside is going to look at the back of the hole. Now I can change the degrees, I can make it flat, I can make it custom, but if you're going to use some kind of screw or you're going to insert something in it, sometimes you want to have it at an angle so that it fits a little easier in there. So I'm going to leave this one at 118, and now we get to the tap depth. How far back do you want your threads to actually go on here? As you see here, this is the threading. So we know that this is going to be a 1 inch. So I'm going to come in here and set this to a 1/2 inch. A 1/2 inch is 12.7 millimeters. And then I'm going to leave the rest of it alone. Okay. So tap clearance, that's exactly where it's going to be. It's only going to be found at the very tip. Okay. And that's going to match whatever I'm going to do for my other part that's going to get attached to that. Now I'll leave the rest of this alone, and I can just right there start from the sketch plane. And that's it. That's all you have to do to create that hole. I just clear this out and it's done. Now, you're not going to see it when your project is created. You won't see it at all. But you will see it when you do a drawing sketch, and you can dimension it out in the drawing sketch. So let's take a look at how to use the external on my second project studio here. So I'm going to switch over to this project and this part studio. So this is just a simple circle extruded out to 8 inches. And for this one, what we're going to do is we're going to come back in here, and we are going to take not the hole, but the one next to it, which is the thread, external thread. So we're going to use the external thread right now. And for this to work, you need to click on the edge that's going to represent where you want this to start. So we're going to click on this corner right here, edge of the top circle. And now I'm going to go in here and I'm going to make sure I have everything matching the way I want it to. Okay, so we first have the ANSI is the standard. This one only gives you 2 options, ANSI and ISO. We're going to stay with ANSI. We're going to say it's exactly 1 inch for this area. We're going to say we want to have the threads per inch. Now, before I chose the 3/4 inch, okay, and I'm going to try to match it to the way I had it to my hole. So we're going to take the 16, okay, and then I'm just going to make sure that my measurement here is the same. I'm going to just achieve it here at that, at 1/2 inch. And now this matches a lot the same. Now there's one more thing we can do. We can add a chamfer on here that is at the very tip and at the angle that we want. And when it does, it adds that for you already. And so you have your chamfer, and that'll fit better in the hole that has the 118 degree. Now you can't go a full 118 degrees right now because the way we have it set it up. But if you played around with this and you were to drop this a little further down, then you can do that. And you can also do an undercut in here, and that would add a hole down here at the bottom of it, but we don't need to undercut it because we don't have to worry about it fitting around anything else. So I'll just finish the assembly right there. And then that's it for that part. So one thing I wanted to go over finally is that when you try to assemble something like this, it's really simple to do. So I'm going to come up here and I'm just going to take my cylindrical mate. So when I use a cylindrical mate, you got to remember 2 things: how and where you want to connect this. So for the cylindrical mate, what I'm going to want to do is I'm going to want to see the very front of this connection right here. And that's going to be my first mater. right there. And then when I come around here, what I'm going to want to do is I want to take on the hole. When I do, I'm going to see this. Now I'm going to hold down the shift key to keep the hole open, because if I move my mouse right now, this will go away and I won't see it. And then I can choose the one I want. So I chose the front of the hole, hold down the shift key, and if I click on the back with the cylindrical mate, it now creates a second part, and this thing should slot right into it, and then we are done mating these guys. So there you go, and let's go. And that's our cylindrical mate right there. Now, you don't have to do this, but I will go ahead and just come in here into my second mate connector right here, and I'm just going to edit it, because even with this cylindrical mate, it can still twist. So what I can do is I'm going to come in here and I want to edit it, and I want to activate the limits on it, and because I don't want it to turn. So once the limit comes up, what you're going to do is just make sure you take the Z rotations here and just make them 0. And once you do that, then you have a completely immobile shape. And basically, I just created a wannabe Thor's hammer. Pretty simple. So that's it for that. Like I told you before, you're not going to see the threads normally, but when you come into your drawing, you can dimension them out. And so here are the dimensions for the hole here. It shows you the width, the diameter of the circle, how deep it goes, what the universal size is, how many threads per square inch, and where the tap distance is. And then again, here is, you can also dimension out the same thing for the other side. You'll see them as dashed lines here. I'll zoom in a little so that you recognize that those are there. And you can just dimension out the rest of it, and you can see all the parts. And this will generate itself for you by using this right here, the hole and thread call out. If you want to, that's up to you. All right, guys, thanks for watching. Bye.